Okay, this is part 2 of the ionic bonding video, and we just finished talking about the different types of ions, looking at cations and anions. Cations are positive and anions are negative. It's kind of just the general distinction between positive and negative. And polyatomic ions are groups of atoms that have a charge. Then we also talked a little bit about Lewis structures, and that's what we're going to continue in this video. That Lewis structures are a visual representation of the valence electrons, and we show their stability using the dots. And so we write the element symbol, and then we can put up to 2 dots on each side, making a full Lewis structure have 8 dots. And that's really handy because 8 means stable. Also, 0 means stable. If you remember to the metals, they can give away electrons to become stable in like the previous energy level. So 8 is stable for kind of those nonmetals that are going to gain electrons, and 0 is stable for the metals that are trying to give away electrons. So let's apply that for aluminum and nitrogen here. Aluminum is our metal, it's going to be giving away electrons, and nitrogen is our nonmetal, it's going to be gaining electrons. And if you notice, nitrogen has kind of these open spaces where it does not have valence electrons. If it were full, I'm going to draw boxes where it would be full. So those are our like empty spots here. And then we have 3 electrons in aluminum, and nitrogen has 3 empty spots to become stable. How convenient. So the 2 are going to work together because opposites attract, and our metal is going to give its electrons to the nitrogen. And that's how an ionic bond works. So we're going to draw arrows to show this transfer. I'm going to take this guy and put it in that. Put that there. Put that there. And now we're stable because the aluminum has given away all of its electrons, and the nitrogen has filled up its octet. And now they're both working together to become stable and follow the octet rule. So our description is that aluminum gives 3 electrons, and then that becomes stable, and nitrogen takes or gains 3 electrons. And as a result, aluminum giving 3 electrons away is going to make it have a positive 3 charge. Remember, a neutral atom has equal protons and electrons. If I give away 3 or I lose 3, now I have more protons in my ratios, 3 more protons, making it a positive 3. So my cation is going to be aluminum with a positive 3 charge. When we write charge, we write it as a superscript at the top with the charge, if it's plus or minus, positive or negative charge, and then the number of how many protons or electrons are extra. So that would be 3 extra protons since we gave away 3 electrons. My anion, that will be my negative, will be the one that has extra electrons, the one that gained electrons or took electrons. That would be nitrogen in this case. And it has 3 extra. So you'll notice aluminum gave 3, it has plus 3, nitrogen took 3, and it's negative 3. Now to write the chemical formula, you can look at your picture and just count how many of each atom. This one's really straightforward because it's just 1 of each. And our chemical formula would be aluminum 1. Nitrogen 1. These subscripts at the bottom are used in a chemical formula to tell the quantity. I'm writing a 1 because this is kind of our first time writing our own chemical formulas, and I want you to know subscripts tell quantity. However, 1 is implied, so we do not need to write 1s, but if I had 2 nitrogens, then I would want to write a 2 as a subscript. So just to clarify that, quantity is told in a subscript, charge is shown in a superscript. Let's look at modeling ionic bonding. On number 1, you're just going to use that property that ionic bonds are made of a metal and a nonmetal. So use your periodic table and find the ones that are made of a metal and non-metal. Let's look at number 4, because this is another one of drawing Lewis structures. We're just going to practice it again of ones that might be a little more complicated. So aluminum and sulfur, let's use Lewis structures to show their electron transfer, then write the chemical formula. I just want to tell you up front, whenever you're doing these, you'll never use more than 3. So if, as you're working through these, on the other one we just use 1 of each because it worked out really nicely. But as you're going through these, if you start using so many of the elements, 3 is the most you'll use of each in drawing these. Just kind of a rule of thumb there to help you guide you. So let's start again. We have aluminum by drawing its Lewis structure. And we already figured out aluminum, that's in group 3A, so it has 3 valence electrons. I'm going to put them as dots around the sides. And sulfur, that's in the group 6A, so it has 6 valence electrons. So if we start doing our little transfer game here, we have 2 spots in sulfur that are open, but we have 3 aluminum electrons that need to be given away. So what we'll have to do is start adding in more sulfurs or more aluminums until we've balanced out all of our electrons and everything in the metals have been given to every open spot in the nonmetals. So if we start moving our electrons over, you will notice we've filled up the sulfur, but we have an extra aluminum still over here at the bottom. So let's add another sulfur with its 6 valence electrons. Every sulfur has 6. And again, it has 2 open spots. I'm going to transfer an electron over, but now I still need my sulfur to be full. So I'm going to add in another aluminum. With 3 valence electrons. So I will take one of these and put it over here. Okay, now that sulfur is full, but you're starting to see how this will work out. If I add one more sulfur, then we're going to be in business. Because again, it has 2 open spots, and I have 2 electrons left on my aluminum to fill. So this looks sort of like a hot mess, but you should see that you have been able to fill 6 total spots with 6 electrons from aluminum, 2 to each sulfur. Kind of thinking about least common multiple. If you like to think about math, aluminum each needed to give 3, sulfur each needed to gain 2. So between the 2, they had to do a swap of 6. In order to do that, it required 2 aluminums and 3 sulfurs. Okay? So our ionic compound this time is going to have 2 aluminums in the chemical formula and 3 sulfurs. Each aluminum gave 3 electrons, so my cation, again, is going to be aluminum plus 3. And this should match that trend we talked about in the part 1 video. The 3A group, that's where aluminum is at, they give away their electrons. Every single element in the 3A group will make a plus 3 ion every time, because they always will have 3 valence electrons. And sulfur, being in the 6A group, they are always going to be gaining 2 electrons, meaning that they will have a negative 2 charge. Now lastly, to write the chemical formula, we have, remember, always write the metal first. We have aluminum. Because now we're giving quantity, we're going to write these as subscripts. As charge, we wrote them as superscripts. Quantity now in the chemical formula, subscript, that's at the bottom. We used 1, 2 aluminums. Ruh-roh. So that would be aluminum 2. And we have 3 sulfurs. So there's our chemical formula. Al2S3. The rest of these, like I said, you will never use more than 3 of an atom when you're doing the electron transfer. If you find yourself trying to do more than that, then you've made a mistake. So for the other 3, draw your Lewis structure and then transfer the electrons, write the cation and anion, and then also the chemical formula.